In section 1.1, we will introduce the concept of a linear equation. An equation indicates that two algebraic expressions are equal. A linear equation in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers and a is not equal to 0. Let's determine whether the following three equations can be classified as linear or if they are not linear, which we say is nonlinear. In the first case, we have 8 times x squared plus 4 times x is equal to 62. I do see a problem here. We have the variable x occurring to the second power, which is not something that we can force to be in the form ax plus b equals c, where x only appears to the first power. So we will say that this first equation is a nonlinear equation. In the second case, we have 4x minus 1 divided by x plus 12 is equal to 3. And this is not linear either, because even though we technically could multiply both sides by x plus 12 and get the desired form, in doing so, we're going to introduce what is known as a possible extraneous solution by violating some restrictions. We see here that if x was negative 12, that denominator would be 0, and that is a problem. Linear equations cannot have such restrictions. Therefore, we say that this is also a nonlinear equation. In fact, we'll learn later in this course that this is referred to as a rational equation because one of the two sides is written as a ratio of two polynomials. For example 3, we have 9x minus 13 is equal to pi times x minus 2. At first glance, this may not appear to be linear. However, without introducing any violations or restrictions, we can do the following. We can subtract pi times x from both sides. And so on the left, we have 9x minus pi times x minus 13 is equal to negative 2. Then if we add 13 to both sides, we get 9 times x minus pi times x is equal to 11. And on the left-hand side, I have x as a common factor. So I could write this as 9 minus pi times x is equal to 11. This 9 minus pi is a constant. It's a fixed number that could represent the coefficient a in our desired form. And we have here that it is multiplied by x to the first power. I don't see any other constant being added on the left. That just means that b is 0, right? And on the right, c would be 11. That means that this is, in fact, a linear equation. I went into a lot of detail here, but you're going to be looking simply for whether x appears to the first power only, and also making sure that x doesn't appear in a denominator or under some sort of restriction like a square root. Now let's talk about how to solve linear equations. We have two examples here for us to work through together. The first is that negative 4 times x plus 1 minus 4 times the quantity x plus 1 is equal to negative 6x plus 1. Our goal is to isolate the x variable, get it all by itself on one side of the equation. First, we're going to distribute what we have here on the left so that then we can group like terms and start simplifying. So we have negative 4x plus 1 minus 4x, and be careful here that negative 4 is going to be distributed with that positive 1. Negative 4 times a positive 1 is a negative 4. On the left, let's combine like terms. We have a negative 4x and another negative 4x. That's going to give us a negative 8x when we add them together. And then we have a positive 1 with a negative 4. That's going to become a negative 3. Now, this looks a lot simpler than what we started out with, which is wonderful. Our next task will be to group the x terms on one side of the equation and then group the constants on the opposite side of the equation. So to do this, I am going to add 6x to both sides, and that's by choice. We certainly could have added 8x to both sides to get the x terms on the right. So you do have a choice there. Negative 8x plus 6x is negative 2x. Then we have minus 3 equals, notice that these two now add up to 0, so we just have 1 on the right-hand side. Next, we're going to group the constant terms on the right-hand side, and so I am going to add 3 to both sides. So we get that negative 2x is equal to 4, and by dividing both sides by that coefficient of x, which is negative 2, we get that x is equal to negative 2. That means that when x is negative 2, that equation becomes a true statement. The two sides are equal. I encourage you to substitute negative 2 for x to confirm this. In the second example, we have some fractions. 2 over 5 times x is equal to 3 plus 1 over 3 times x. Here, the coefficients of the x variable in both sides of the equation has a fraction, and there is a simple way to avoid having to work with fractions by clearing them from the very first step. To do this, we can multiply the two sides of the equation by the least common multiple of 5 and 3, the two quantities that appear in the denominators. The least common multiple of 5 and 3 is 15. So if we multiply both sides of the equation by 15, we should be able to clear those fractions right at the very beginning of the problem. While this is not required, I find that this certainly makes things a lot simpler. So now let's see how this helps. We have 15 times 2 is 30, and 30 divided by 5 is 6. So the left-hand side becomes 6x. On the right-hand side, we have to distribute. So first we have 15 times 3, that's going to be 45. And secondly, we have 15 times 1 is 15. Then divide that by 3, we get 5. So that coefficient now becomes a 5. Looks like we only have one step to go, and that is to group the x terms together on the left-hand side is more convenient in this case. So by subtracting 5x from both sides, look what happens. We get x on the left, 45 on the right, and that becomes our solution.